Good morning. Sorry, my Zoom is running slow this morning. I could not get it to connect. Hopefully there won't be a lag today.
So how are you doing today?
I am good. How are you?
Great.
Do you have a good first week? You finally getting settled in, trying to figure everything out?
Yes, ma'am.
Good.
How long has Sarah Kate not been in our class?
I guess she didn't sign up for this. I guess she may be taking it with Mr. Perry.
Yeah, because I actually sent her the work that you sent me,
Oh.
thinking she was in the class. So
Yeah, no, she's in Mr. Perry's class, I think.
oops.
Yep. I'm sure she didn't mind.
She was a little mad.
Okay, I'll give it a couple more minutes. Let's see, we should have Easton should be joining today, and then we should have April. Hopefully she won't oversleep. So I'm going to be right back. Hang on just a minute. All right. Sorry about that. The dog decided she was coming inside, and I realized that she didn't have food and water. To get her situated so she'd leave me alone. Still waiting on Easton. I'll tell you what we're going to do is go ahead and pull out your homework. Hopefully, did everybody get it uploaded okay?
Yes, ma'am.
Awesome. Very good. Go ahead and get that out. Here comes Easton. And we're going to go ahead and go through those homework answers. I'll call them out, give y'all a chance to check it, ask questions if there's anything that you're not sure about. Good morning, Easton. How are you?
Good, how are you?
I'm good. Good to see you. We missed you last week. Did you hear the video? Did you see the video on the first day?
Yes, ma'am. I saw both.
Easton? So anyway, and then my crazy brain, and then I was like, oh my goodness, his mom told me they were going to be gone. So anyway, did y'all have a good trip?
Yes, ma'am.
Awesome. Very good. So since you're kind of our guinea pig, were you able, like, just in watching the videos, were you able to kind of follow what was going along? Were you okay with that?
Yes, ma'am. It was like the same thing. It's just, It was very simple.
Well, good. So hopefully, and I guess, I don't know if you watched any videos last week or not, Keely, after you left a little bit early. But anyway, so it's just kind of, that's good to know that if anybody does have to be out for any reason, oh, here comes Claire Jane, then that'll be helpful to know that that it does do okay. Okay. What I was telling them, and I'll get Claire Jane connected. Good morning. So we're going to get ready and kind of go over our homework. I just want to read through the homework answers, and then if you have a question, stop me, ask, we can work through it and all that good stuff. Okay. So I'll give you a chance to get your papers ready. Claire Jane?
Yes, when you submit your homework into the website, there's an
Yes.
effort and an accuracy. Which one do you submit it to?
To the effort. You can submit it to both if you want to, but to me
Okay.
that's twice the work.
I
But
just submitted it to the first one. Is that
Okay.
wrong? Do I need to check it?
it's fine. It's fine. What I had put in the email was just to submit it to the effort one,
Okay.
and then I can pull it from there to grade it, to put in the accuracy grade. So, and if you end up messing up and putting it in one versus the other, when I see that you've only submitted it to one tab, it's not a big deal. I mean,
Okay.
I can pull it for the other. So don't stress about that too much, but you know, in a perfect world, submit it to the effort tab or the effort assignment. And then, so anyway. Okay. All right. So we will go ahead and, since I'm going to email and text, I wonder if I have April's mom's number to text and say, April, get up. Let's see. Okay. All righty. So we'll go ahead and go through the homework answers. So we'll start on page 6. All right, if I need to repeat anything or whatever, just let me know. So page 6, we had 2 through 32 evens. Page 6, 2 through 32 evens. Okay, so number 2 says, how can you prove that a conjecture is false? And the answer would be by using a counterexample. The counterexample is what we found that we could prove that a conjecture is false. Number 4, we have the stars, and so basically you've got it says to sketch the next figure in the pattern. So in the first one, you have the triangle to the left. In the middle one, you've got the triangle up. And the third one, your triangle has moved to the right-hand side. So obviously, if you kept on in that pattern, it would be in the bottom right triangle would be your shading. Okay. Number 6, it says describe a pattern in the sequence of numbers and predict the next number. So we went 0, 1, 4, and 9. And so it says, so if you look at that, 0, 1, 4, 9, did you figure out that these are all perfect squares? 0 times 0 is 0. 0 times 1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So your next number would be 4 times 4, which is 16. Did you see that pattern? Number 8, we have 3, 0, negative 3, 0, 3, 0. So we're doing odd numbered terms in the sequence between 3 and negative 3. So your next number would be negative 3. All right, any questions so far? All right, number 12, jumping down, sketching the patterns. So you can see that the first pattern we have, it is broken into halves. Then it goes fourths, and then it goes sixths. So what would be the next one?
Eighths.
Eighths, good. So you would break your pattern into eighths. Good job. All right, and then number 14, you can see where we have the first one has the top little triangle is shaded, and then the bottom one is unshaded. But then it turns, and then you've got 2 shaded on the right. But you can't tell that it's, I mean, you can tell that it's 2 because it's gotten bigger, but you don't have a line dividing them. So 2 are shaded on the right-hand side, 2 are unshaded on the left-hand side. Then it turns again. We have 3 shaded on the bottom, 3 unshaded on the top. So your next pattern would be turned to where you would have 4 shaded on the left-hand side and 4 unshaded on the right-hand side. That makes sense? Awesome. All right, number 16, again, we are describing number patterns. So 16, we have 1, 4, 7, 10. And so you can see that each number is 3 more than the previous number, so our next number would be 13. Number 18, 1, 11, 121, 1331. We can see here that each number is 11 times the previous number, so the next number would be 14,641. Number 20, 7, 9, 13, 19, 27. This one's a little more challenging. Okay, so if we go from 7 to 9, you can see that the numbers are the after the first are found by adding consecutive multiples of 2. So 7 plus 2 is 9. 9 plus 4 is 13. 13 plus 6 is 19. 19 plus 8 is 27. So then you would add 10 to 27 to get 37. That one was a little more of a challenge. So you saw that you were adding 2, then 4, then 6, then 8, then 10. 22, I have 256, then it goes to 16, then it goes to 4, and then it goes to 2. And so each of these is the square root of the previous number. The square root of 256 is 16. The square root of 16 is 4. The square root of 4 is 2. So what is the square root of 2? We just leave it as the square root of 2, okay? You would leave it as a radical with 2. Any questions so far? Anything that you're not quite sure why it was what it was? Awesome. All right, we'll move on over to page 7. So in page 7, it says we're visualizing patterns again. The first 3 objects in a pattern are shown. How many blocks are in the next object? So you can see the first one, we have the 1 block. And then it has 3 blocks on the bottom, and that 1 block shifts to the top. And then the next one, we have 5 blocks on the bottom, 3 and 1 shift up. So you can see here that we are going by odd numbers. So the next block we should have 7 on the bottom, and then 5, 3, and 1. Okay, so it should be odd numbers starting with 1 on the top. You should have 1, 3, 5, and 7 as far as your blocks. All right, and then the next section, we are using the picture 1, 2, 3, 4, 5 to use for 26 through 28. Okay, so 26 says find the distance around each figure and organize your results in a table. So what we're talking about is how many sides does the first block have? So if we were going 1, 2, 3, 4, the distance around the first block would be 4. Okay, the second block, I'm going 1, 2, 3, 4, 5, 6, 7, did I count? 8. Okay. Oh, there's April. Here she comes. Okay, so the second block is 8. The third, we would have to go up 3, to the right 1, down 1, right 1, down 1, right 1, down 1, and then left 3. So the distance around that one is 12. And then the fourth one, we'd have to go up 4, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, and then to the left 4. So that's a total of 16. And then for figure 5, we have to go up 5, right down, right down, right down, right down, right down, and then to the left 5, so our total is 20. Any questions about that? Everybody okay with that? Awesome. Okay, and number 28 says predict the distance around the 20th figure in this pattern. Okay, so if we look at this, if we look at our table and we said figure 1 had 4, 2 had 8, 3 had 12, 4 had 16, 5 had 20. If we continued on to the 20th figure, notice we're counting by 4s each time. We went from 4 to 8 to 12 to 16 to 20. So you should be able to predict that the 20th figure would have 80 units. The distance would be 80. Any questions on that? Good morning, April. We are going over homework. We just went over number 26 on page 7. So we're checking our homework. All righty. Actually, I'm sorry, that was number 28. All right, let's go on to 30. The product of any two odd numbers is, so we looked at the pattern, 1 times 1 is 1, 1 times 3 is 3, 3 times 5 is 15, 7 times 11 is 77, 13 times 19 is 247, 201 times 305 is 61,305. So by looking at this pattern, we can see that any two odd numbers multiplied together will give you an odd number. So the product of any two odd numbers is odd. 32, using a calculator. It says use the calculator to explore the pattern. Write a conjecture based on what you observe. So 101 times 34, then 101, let's see. 101 times 34 is 3,434. 101 times 25 is 2,525. 100 times 97 is 9,797. And 101 times 49 is 4,949. So you see that pattern, 34, 34, 25, 25, 97, 97, 49, 49. So you can see that every time you multiply 101 by a 2-digit number, the 4-digit number are those 2 digits following each other. All righty, so that was pages 6 and 7. Let's turn to page 8. We had 34 through 38 evens. Okay, in this first section it says finding counterexamples. Show the conjecture is false by finding a counterexample. And number 34 says all prime numbers are odd. What is the one thing that kills that? What is a prime number that is not odd? It is the only prime number that is not odd.
2.
2. Good job. 2 is prime, not odd. So that's our counterexample for 34. Number 36, it says if the product of two numbers is even, then the two numbers must be even. Okay, so saying if I multiply two numbers together and my answer is even, then the two numbers that I multiplied together must have been even. And what would be an example of that? Anybody come up with anything? What if I multiplied 2 times 3? I have an even times an odd. That still gave me an even answer. Okay, so my counterexample for that would be I could multiply an even and an odd and still get an even answer. Okay, so I can't just assume that those two numbers that I multiplied together were both even, because it could have been an even and an odd. 38, the square root of a number x is always less than x. The square root of a number x is always less than x. The time that this is going to go into effect is going to be when you have like, the example they've given in my book is having the square root of 1/4. If I take the square root of 1/4, so I've got my fraction 1/4. I can hook up my iPad real quick. Let's see. Go back to Zoom. Share screen. Okay, so what the counterexample for that would be is if I'm dealing with a number that is less than a whole number. Okay, so if I have the square root of 1/4, then that means I've got the square root of 1 over the square root of 4. The square root of 1 is 1. The square root of 4 is 2. Okay, so if I've started off with 1/4, that is going to be less than 1/2. So in that sense, if this was x, then the square root of x is actually smaller, I mean, is larger than 1/4 and is larger than X. So that's our counterexample in that situation. As long as it's a number that is going to be less than a whole number, okay, that's when we're going to see that. Okay. Dealing with Goldbach's conjecture, it says in 40 and 41, use the list of the first 5 prime numbers given below. Okay, so 2, 3, 5, 7, 11, blah, blah, blah. I said first 5, the first prime numbers. So number 40 says, show that Goldbach's conjecture is true for even numbers from 20 to 40 by writing each even number as a sum of 2 primes. Okay, so think about the number 20. Okay, so Goldbach's conjecture, so we're thinking about like the number 20 can be the sum of 2 primes because that could be 3 plus 17. Okay, 22 could be 5 plus 17. 24, prime numbers that make that, 5 plus 19. 26, that could be the sum of 7 plus 19, or you could do 5 and 21. I mean, so there's more than just these answers. You may have come up with 2 other primes. 28 could be made up of 11 and 17. 30 could be made up of 13 and 17. 32 could be made up of 13 and 19. 34 could be made up of 17 plus 17. 36 could be made up of 17 and 19. 38 could be made up of 19 and 19. And 40 could be made up of 17 and 23. But again, there could be other numbers to make it up. So it just says, when we look back at page 5, dealing with the conjecture, you can see that every even number greater than 2 can be written as the sum of 2 primes. All righty, 42. Did we do 42? We didn't do 42. Am I going too far? We just did through 38. So y'all didn't even do that. Y'all got to stop me. Y'all are probably going, was I supposed to do that? Okay, so page 9, we have 60 through 70 evens. Page 9, 60 through 70. So number 60, we're evaluating the expression 3 squared equals 9. 62, negative 4 squared is 16. 64, 3 squared plus 4 squared is going to equal 25. 66, negative 2 squared plus 2 squared equals 8. 68, write the next number in the sequence, 1, 5, 25, 125, and 625. And then number 70, 3, 7, 11, 15, and my next number would be 19. Any questions on pages 8 or 9?
How did you get 8 on number 66?
Okay, so on number 66, I have negative 2 squared in parentheses plus 2 squared. Okay, so remember, if my negative is inside parentheses, that means I'm doing negative 2 times negative 2 plus 2 times 2. A negative 2 times negative 2 is going to be a positive 4, and then 2 times 2 is 4, and 4 and 4 is 8. Okay, so if the negative is inside parentheses, like negative 2 squared, that means I'm multiplying negative 2 times itself. If the negative is not inside parentheses, then this means the opposite of 2 squared. So then that would be negative 4. Okay, so if it's outside parentheses, I'm going to have a negative solution because I'm reading this negative in front of it as the opposite of 2 squared. Okay. All righty, so that was 8 and 9. Let's go ahead and turn to 13 and 14. Jump a couple of pages, 13 and 14, dealing with our lines and planes and points and all that good stuff. Page 13, we had 10 through 26 evens. 10 through 26 evens. All right, number 10, A, B, and C are collinear. That is false. 12, A, B, and C are coplanar. That is true. 14, D, E, and B are collinear. That is true. 16, D, E, and B are coplanar. That is true. Any questions on those? Collinear, same line. Coplanar, same plane.
Could you repeat the questions?
Yes.
Could you repeat the questions?
I'm sorry. Number 10 was false. 12 true, 14 true, 16 true. Moving on to number 18, we're naming a point that is collinear with the given points. So if I have G and K, a collinear point would be N. 20, if I have M and J, a collinear point is F. 22, if I have K and H, a collinear point is F. 24, if I have J and F, a collinear point is M. Any questions about that? All right, and then 26 says name 3 points in the diagram that are not collinear. So for 26, I can see that R, S, and T are not, or you may have used R, U, and T, or you could have used R, V, and T, or S, U, and T, or S, V, and T, or U, V, and T. Okay, there's all kinds of different options here. You just had to pick 3 that were not collinear. Any questions on that? Great, page 14, 28 through 54 evens. 28 through 54. So number 28, name a point that is coplanar with the given point. So when I have A, B, and C, D is coplanar with A, B, and C. When I have G, A, and D, H is coplanar. A, B, and H, my point would be E. And A, B, and F, my point is G. Any questions on that? Awesome. All righty. So now let's take a look at 36, naming non-coplanar points. Name all the points that are not coplanar with the given points. So if I have N, K, and L, the points that are not coplanar would be P, Q, R, and S. 38, if I have P, Q, and N, my non-coplanar points are going to be K, L, R, and S. 40, if I have P, Q, and R, my non-coplanar points are K, L, M, and N. 42, if I have P, S, and K, my non-coplanars are L, M, Q, and R. Any questions on those?
Could you repeat 38?
38, we were given P, Q, and N, so the ones that are non-coplanar would be K, L, R, and S. All right, the next one says complete the definitions. We're going to complete the sentence. It says segment AB consists of the endpoints A and B and all the points on the line AB that lie blank. And my answer would be between A and B. So for it to, if there were any other points that were between A and B, then segment AB would include all of those. 46, 2 rays or segments are collinear if they lie on the same line. Okay, so our 2 rays or 2 segments are going to be collinear as long as they're on the same line, because remember, collinear means together on a line. All right, 48. What I'll do is I can draw a couple of samples for these. So 48, it says to draw 4 points, J, K, L, and M. Okay, so I'm going to draw 4 points, J, K, let me make my and thicker. Okay, so if I had J, K, L, and M, okay? So I drew my 4 points, no 3 of which are collinear. And then it says to sketch ray JK. So if I did JK, I know J is my endpoint and it's going to go through K. So I made a ray. I have an endpoint and a point. And then it says I need to sketch segment KL. So that means K and L would be a segment. Okay. They're not exactly touching, but it's okay. Line LM, that means L and M. I'm going to have a line with my arrows. And MJ is going to be array. So I'm going to start at M, go through J. Whoop, it didn't, whoa, what was that? Start at M, and I'm going to go through J to make array. Okay. Your figure may look totally different than mine, and that is okay because we could have put those 4 points anyway. We could have shifted them around. They could have been in a different configuration. The main thing is just making sure that you followed the directions and used array or a segment or a line whenever you were supposed to. Okay, so don't stress that these don't look exactly the same as what you may have. Number 50 says draw 2 points X and Y. So if, let's see, it says 2 points X and Y, and it doesn't say, you know, we just have 2 points. So I'm going to have point X and point Y. And then it says sketch line XY. So that means I've got to have a line that goes through both of them, arrows on the end. And then it says add point W between X and Y, so that I have array WX and array WY. So that means I'm going to have my point right here in the middle. So now I can see that I would have array going that way and array going that way. Okay, you don't have to have the arrows you do not need. Whoop, cancel. You would just have to have that point in the middle. So now you have opposite rays with W as your endpoint. All right, and then number 52. In the bottom, it says, what kind of geometric intersections do we see in the photographs? And so is it the intersection of 2 lines? Is it the intersection of a line and a plane? Or is it the intersection of 2 planes? So you can see that 52, my tracks, how they intersect, that would be the intersection of 2 lines. Just so you can see you didn't have to do 53, but if you're looking at the 54, you could see that we have a line intersecting a plane. And 54, the mirrors, the way they're coming to we've got 2 planes intersecting at a line. Okay, so we have intersecting planes and nothing. Any questions on 14?
What is number 54 again?
54 would be the intersecting planes, because the mirrors would each be a separate plane, and we can see where we've got that line down the middle. Remember, 2 planes intersect at a line, so we can see where those 2 planes intersect.
That makes so much more sense. I was so confused by that. I was like, what is this?
Yeah, what in the world is this? Yeah, but now hopefully you can see it. Okay. That's why we're going over this stuff. I want to make sure that y'all are understanding, because there may be some things that once we go through it, you go, oh, aha, okay. All right, page 15, we had 56 through 66 evens. 56. Now on this, we have a cube, and we're looking at the lines, and we're trying to see, in the beginning, we're looking to see what points they intersect at. So 56, I have line AD and line AE, and they both intersect at point A. Remember, if I've got intersecting lines and I have a repeating letter in each line, that's my intersection point, okay? And then 58, plane ABC and plane DCG intersect at line DC. 60, plane EAD and plane BCD intersect at line AD. Any questions on those? All righty. And then we have 62, we're sketching figures. So 2 lines that lie in a plane but do not intersect. Okay, so basically I could have, here's a plane, and here's a plane. Okay, but I can see that they don't intersect. 68. Did we do through 68? No, we did through 66, so that's it. Oh, wait, no, that was 62, sorry. 64. 3 lines that intersect in a point, but do not all lie in the same plane. So, okay, so 64, 3 lines that intersect in a point, but do not all lie in the same plane. Okay, so if this was our plane, I'll slant it just for fun. Okay, here's our plane. And I could have a line going this way and a line going this way. And so those intersect, but now I've got to have that third one that's going to intersect, but they're going to be in different planes. You remember how we talked about that pencil that sticks through our paper? So if it intersected at this point and then the dot, dot, dot is going to show me where it goes, whoop, underneath it. And then it would stick out there. So I could see where I'd have 2 planes going this way, but then I'd have the one that's going up and down. And so it's in a different plane than those 2 going side to side. 66, 2 planes that do not intersect. I'm sorry, I gave y'all 66. This was number 66. You're probably wondering what in the world I'm doing. This was number 64. I need to go back and do number 62. I jumped. 62, 2 lines that lie in a plane but do not intersect. Those were lines in a plane, not 2 planes and not intersecting. So if I have parallel lines or 2 lines that will never intersect, they're in the same plane, but they cannot intersect. Okay, so if you're ever asked to draw lines that do not intersect, you know that they're going to be parallel. And they could have gone like that or side to side, either way. Okay, but remember that parallel lines are the only lines that do not intersect. Do y'all remember why? From graphing? I remember from Algebra 1, why 2 parallel lines cannot intersect? What do we know about their slopes?
They're
What
the
are the-
same.
They're the same, good job. So parallel lines have the same slope, so they can never intersect because they're the same distance apart at every point along the line. Good job. All righty, so that was 56 through 66. And then-
Quick question.
Yes.
Sorry, quick question on number 64.
Yes.
I like way overcomplicated that, and so I drew like this crazy thing, but I was just wondering if it's still right because I don't even know. I just like drew this whole thing, so like I can. Is this still right? Hang on, like that.
Oh, wow. Yes, that's exactly right. You just drew the planes. Very good.
Okay.
So you actually drew the intersecting plane. So it's, yeah, so that's basically the same thing. If we would have drawn the plane that this arrow was going through, that would have been exactly the same. Good job.
Okay. Thank you. I was just worried that I overthought
Very-
it and just did it completely wrong. So
No, you overthought it, but you did it exactly right.
thank you.
Okay, and then our last page. Woo, finally. We have got page 21, number 6 through 12. So it flips several pages over. 21, 6 through 12. All right, so on this page, we were doing the guided practice that went along with this new section. And all right, starting at number 6, we're finding the distance between the 2 points. So we had to use the distance formula. Remember distance formula? We have got D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we've got to use that distance formula here. So for number 6, when I plug in my points, you should have ended up with 2 times the square root of 17. Now you may have ended up with what, the square root of 34? But if you didn't, that would be if you didn't simplify, because the square root of 34 simplified would be, no, that's not right, not the square root of 34. Hold on a second, let's see. let me back into that. You would have had 4 times 17 would be 56, the square root of 56, because that would be the square root of 4 times 17, which would be 2 times 2 times 17. So that's where we pull our whole number 2 out. Okay. So if you
Is
ended
this
up with the
number
square,
6?
I'm sorry?
Is this number 6?
Yes.
Okay, I got 68.
Okay, so let's go ahead and take a look at that real quick. So if we're plugging in and we have d equals the square root of, let's see, 0.2x is 3, so I'd have 3 minus 1 squared plus y is 5. I'd have 5 minus a negative 3 squared. Okay, so this is where we've got to be super careful because I have 5 minus a negative 3. 3 minus 1 is going to be 2 squared plus 5 minus a negative 3. Remember here, I'm going to need to change this to plus a positive. So I'm going to end up with 5 plus 3 is 8 squared. What did I do wrong? Three minus 1, 5 minus a negative 3. D equals the square root of 4 plus 64, that is 68. Maybe I just did I backed into the problem wrong. So square root of 68 is going to be the square root of 2 times, oh, that's what I did. Sorry, I messed up. As far as my backing into it, the 56 there is wrong. 17 times 4. Yeah, I calculated wrong. It should be 68.
Is the answer 68 or is it the square root of 68?
Okay, so we ended up with the square root of 68. And so when we simplify that, okay, 2 will go into 68 34 times. Now I have to break down 34. The smallest prime factor of 34 is 2 times 17. 17 is a prime number, so I can see that my 2 buddies that can come out, so I end up with 2 times the square root of 17. So the square root of 68 is correct, but it is not in simplest form. So that would be one of those things where if you did not simplify on a test, I wouldn't count it wrong. I would just count off a point for not simplifying. But do know that if you were taking the ACT, it would not give the square root of 68 as an option. It would only give the simplified version as 2 times the square root of 7. So you need to understand about simplifying radicals, okay? All right, sorry, my book only gave me 2 square root of 6, and when I typed it out, my fingers hit the wrong buttons. Okay, so that was number 6. Number 8, my points are 7, 3, and 1, negative 5. You should have found that your distance is 10, the whole number 10. Any questions on 8?
I got 100. I probably didn't simplify.
Okay, that would be the square root of 100 equals 10. Yeah, so you would have ended up with 100 under the radical. Tyler?
Are we supposed to do 6 through 12 all?
Yes, we were. I'm just jumping. I'm so used to doing evens. I'm sorry.
That's what I thought because you were skipping over.
Sorry. Thank you.
Miss Jennifer,
Yes.
I kind of did the distance formula for all of them.
Okay, well that's what we're supposed to be doing. I'm the one messing up. I clearly have 6 through 12 written on my paper and not evens beside it, and I'm just going evens because that's what I'm doing. Okay, so we did number 6. Number 7. Look at number 7. My points are negative 8, negative 6, and negative 3, 0. You should have ended up with your solution as the square root of 61. And that could not be simplified. Everybody good with number 7, square root of 61? And then number 8, we said was the square root of 100, which simplifies to 10. So your answer should be 10 on number 8. Number 9, you have the points negative 2, negative 6, and 1, negative 2. And your solution is 5. Any questions on that? Did you end up with the square root of 25? You
What
should have
was
ended up.
number 8 again?
Number 8 was 10. And 9 is 5. Clara?
On 9, I got 21.
Okay, so let's take a look at 9. We're dealing with a lot of negatives here. So I've got 1 minus a negative 2 squared plus negative 2 minus a negative 6 squared. So let's take care of all these negatives. I know that this will be minus a negative. And actually, I need the rest of my parentheses there. Okay. And then over here, I'm going to have plus a positive. Okay, so D is equal to the square root of, I've got 1 plus 2, which is 3 squared, plus negative 2 plus a positive 6. I'm going to end up with 4 squared. So 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. So I've got the square root of 25. So D is equal to 5. Do you see where you made your mistake, Clara?
Yes.
Okay,
Did you work out 7 and 8?
7 and 8, sure. Number 7, D equals the square root of, I would have 0 minus a negative 8 squared plus, oh, sorry, I started with Y. Let me just do this. Okay, so starting with my x's, number 7, I've got negative 3 minus a negative 8. Negative 3 minus a negative 8 squared plus 0 minus a negative 6. Sorry, my font in this book is tiny and my eyes are not what they used to be. Okay, so here we're going to fix our minus and negatives, plus positive, plus positive. Got all that checked. D is equal to the square root of negative 3 plus 8 squared plus 0 plus 6 squared. Negative 3 plus 8 will be 5 squared. 0 plus 6 is 6 squared. 5 squared is 25. 6 squared is 36. So 25 plus 36 is 61. 61 cannot be simplified, so we just end up with our answer as the square root of 61.
Miss Jennifer,
What number was this?
That was number 7.
Miss Jennifer.
Yes.
So I wanted to go ahead and tell you now. I got like all of these wrong because I took Y1 and Y2 and used those. I didn't use Y1 and the X1 or like Y2 and X2.
Okay, so do you see, I want you to flip back for just a minute on page 19 in the green box. Do you see your formula in the green box? They have AB, which is the same as the distance of A and B. So the main thing is that equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That's your formula that you're using for all of these. Okay? So what I want you to do is those that you missed, it will be best if you go back and correct them just so you can get that in your brain. So when it comes test time, you get them, you know your formula. Okay? All right, so we did 7. Did you ask, did somebody ask me to work 8 also?
What's the answer to 8?
10. Do I need to work 8?
No, ma'am.
Okay. And then 9, we worked, right? This was number 9. Okay, so any questions on 6 through 9? All right, 10, 11, 12, we had to really practice with the distance formula because we had to find the distance of JK and then find the distance of KL and then compare the two to see if they were congruent. Okay, so what we found was that the distance of JK and the distance of KL were the square root of 65, so they were congruent. Do I need to work that?
What number is that one?
Number 10. Number 10, your answer was the square root of 65, so they were congruent. Or actually, I'll just write JK is congruent to KL. Any questions on 10?
I got the first one I got JK as 65, but when I did KL, I got 5. So I don't
Okay.
really know what I did wrong.
So let's look at just KL. All right. I'm going to have the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to plug in my values. And so x2 on that one would be -5. -5 minus -1. And then the next one would be -5 minus 2. I'm going to go ahead and fix this where I'd have plus a positive. So then I've got -5 plus a +1 would give me -4 squared plus -5 minus 2. That's going to be -7 squared. I'm going to have the square root of 16 plus the square root of 49. And 49 plus 16 will be 65. Do you see where, was it a computation error with the negatives?
Yes, ma'am. Instead of putting -7 in the second one, I put -3. So
Okay, so on that one, remember we can change subtraction to adding the opposite. So I could change that minus sign to a positive, but then I have to change 2 to a -2. Okay, so that's one of the things you can do to remember. But always know if I start with a negative and I take something away, I'm going to end up with a larger negative. If you added 2, then you would have a -3. Okay, I'm glad you saw where you made your mistake. Good deal. We did 10. Any other questions on number 10? Number 11, JK is going to be the square root of 137. KL ends up being 2 times the square root of 34, so they are not congruent. I'll go ahead and write those down. So, whoop. Number 11, JK equals the square root of 137. KL equals 2 times the square root of 34.
Can we work out KL because I got 136?
Okay, so for KL, all right, for KL, our first point will be -2 minus 4. And then for Y's, we will have -7 minus 3. So again, if we need to, we can go ahead and change this to add the opposite, add the opposite. So -2 plus a -4 will be -6 squared plus -7 plus a -3 is going to be -10 squared. -6 squared will be 36. -10 squared will be 100. So we end up with 136. Now we've got to reduce this. Okay, prime factors, 136 divided by 2 is going to leave 68. 68 divided by 2 is 34. 34 divided by 2 is 17. Okay. I have 2 2's that are able to come out as a whole number. So that is going to be 2 times the square root of 34. Did you just end at the square root of 136? Is that what you were saying?
Yes, my answer. I just circled 136 and thought that was my answer. I forgot to simplify.
Gotcha. Yeah, just make sure you simplify your radicals. Okay. Any other questions on 11? Okay. We'll do 12 real quick and then we'll take our break. Okay. So number 12, JK and KL both equal the square root of 34. Any questions on that one? Awesome. Okay. We had a lot of homework to go over, but that's okay. So we'll go ahead and take a 5-minute break. I've got 9:27 on my time. So when we come back, it'll be 9:32. So take 5. If you have questions, let me know.
On number 55 on
Mhm.
page 15, I kind of sort of forgot to do that section.
Okay.
So AB and BC intersect at B, is that correct?
Yes.
Okay.
And on that one, we only had evens to do, 56 through 66 evens.
Oh, okay.
I'll be right back, but I'm just running to the kitchen. So if you need me, just yell and I'll come back. I just need to get my daughter her medicine.
Okay, I'm back.
All righty. Okay, so what we're going to do is we had finished up on this section. This was 1-3 was the distance formula, segments and their measures. We only did the practice with 6 through 12. And so what we're going to do is page 21. We'll do 23 through 30. So let's go ahead and take a look at that on page 21. It just says logical reasoning in the diagram of the collinear points. PT equals 20. Okay, so my whole distance of P through T, points PT is 20. QS is 6. And PQ, QR, and RS all have the same measures. So you've got to figure out what are those measures, okay? So if if QS is 6, and you know that PQ, QR, and RS are all the same, you need to find the lengths, okay? So that'll be 23 through 30. So if we know that PQ, QR, and RS are all the same, and that QS is 6, what does that mean that QR is? Let me go to my page.
3.
Good. Yeah, you can see that since they're the same, if QS is 6, half of 6 is going to be 3. So that's what you'll be doing there. Let me go.
23 through 30.
Yes.
And this is homework.
Yes.
What page?
This is on page 21. Page 21, 23 through 30. And then let's go ahead and turn to page 22. And let's do, let's look at the top of that page using algebra. So it says, suppose M is between L and N. Use the segment addition postulate to solve for the variable and then find the lengths of L and M. So real quick, let's flip back for a minute to the segment addition postulate. That was going to be, that's on page 18. Flip back to page 18 for a minute. The segment addition postulate says that if I have AB plus BC, that equals A to C. Okay, that means if I have two pieces and I put them together, it's going to be the two furthermost endpoints. All right. So in this example, we're using L, M, and N. And we've got LM, MN, and LN. So it tells us what those measures are. So you're going to be using that addition postulate, segment addition postulate there, okay? And you're going to use algebra here to solve for x. All right? So in that, like if you look at number 31, you're going to have LM, which is 3x plus 8, plus MN, which is 2x minus 5, equals LN, which is 23. So the problem you would set up is 3x plus 8 plus 2x minus 5 equals 23, and then you're going to solve for x. Everybody good with that?
Are we doing 32, 31, 33?
31, 32, 33 on that one. So that's page 22. Numbers 31, 32, 33. And then we will do numbers 40 through 43. That's going to be distance formula like we did on the previous example, determining if PQ and QR are congruent. So you'll need to use your distance formula there.
I'm sorry, could you say the numbers on page 22 one more time?
Sure. Let me go ahead and say it all. Okay. Let me do all of it that we just went over. Page 21, numbers 23 through 30. Page 22, numbers 31, 32, 33, and then 40, 41, 42, and 43.
Page 31, 32, 33, and then 40.
So on page 22, we have 31, 32, 33, and then 40, 41, 42, 43.
Okay, thank you.
Okay, you're welcome. All righty. So then I want you to turn over to page 24. And we will do numbers 62 through 71.
Page 24, right?
Page 24, 62 through 71.
Oh, what is this doing? Like, what chapter are we doing? Like 61 through 70.
So that is review from earlier sections. The section where we talked about points on a plane, points, lines, and segments. You can see where it says mixed review. Your mixed review is going to cover previous sections. So if you don't remember it, you'll need to flip back and find where we talk about points in a line and a plane and things like that. I think that's section 1, 2.
So 24, 62 through 70.
62 through 71. And you can see in parentheses, see where it says, like for 62, look right above it. In blue, it says review 1.2. So you know that if you're not sure what to do, look back at section 1.2. If you look at number 68, look at the directions above, naming rays, name the ray described. It says review 1.2 for 1.4, okay? So you're just gonna go back and review that 1.2 to be able to answer. All right, okay, let's move on to 1.4 on page 26. We are gonna be looking at angles and their measures. And so, when we are dealing with angles, okay, an angle consists of two different rays that have the same initial point. The rays are the sides of the angle, and the initial point is called the vertex. So you can see here where they've identified these are the sides, the ones that come, the actual rays, and then the vertex is that point where they join. Remember, we previously learned that opposite rays form a line. So opposite rays are going to go straight out. They're going to have that point in the middle, but it's going to make a straight line. This is when we have two rays that connect in any other angle than a straight line, okay? So we have the two sides that are the rays, and then the vertex is that point where those rays join. And it says the angle that has sides ray AB and ray AC is denoted by angle BAC. So I can name these several different ways. In this situation, I could name it BAC, go in that way. Or I could name it angle CAB, as long as I have the beginning, middle, and end, as long as A is in the middle. Or I could just name it as angle A. Okay, so 3 ways to name an angle: angle BAC, angle CAB, or just angle A. Okay, I can either name it by the 3 points from beginning, middle, end, or end, middle, beginning, or just by that middle point. Okay, so that's going to be very important, because you notice that when we're talking about rays, and we've got rays and segments and angles and all these different things, instead of having to actually write out the word, we have these symbols that we can use to denote the name. So it's going to be very important that as you write answers, you make sure you're using the correct symbols with them. Okay. All righty. So it says name the angles in the figure. So it says, if we look at this, I can see that I have PQS. So that's going to be this angle right here, or we could also call that SQP. Okay. I have SQR, which could also be called RQS. Now you can see we have those 2 smaller angles, or we could actually what I'll do, or we can name it by this outer angle, PQR or RQP. So really in this situation, we have 3 different angles. 2 angles put together forms a total of 3 angles.
For the solution, would we have to write all like 6 of those, or we just have to write the 3?
Well, in this situation, yeah, we only have to write 3. And that's one of the things about geometry, just like when we were naming, non-collinear points, there could be 5 possible answers. It's just that your answer has to be one of those possible ones, okay? If it doesn't say list them all and you're just listing one, then just know that, there's going to be lots of times that you may have, more options for answers than you actually need to write. Okay, it says you should not name any of these angles as angle Q, because all 3 angles have Q as their vertex. So if you named it as angle Q, we don't know which angle you're talking about. Okay, so in this situation, you could not name it only by its angle. We could only do that in the one above, because there are no other angles that share angle A. There are no other angles that share that vertex. So if there are more than one angle, you cannot name it just by the angle. All right. Now it says the measure of angle A is denoted by, you see this little symbol here where I have an italicized M and then the angle symbol and then the letter. That means the measure of angle A. So if I was talking about, if I wanted to know what the degrees of angle A would be, I'm talking about the measure of angle A. And the way that we measure angle degrees is using a protractor. Okay, a protractor, you can see across the bottom, we're going right through there, and we know that a straight line is going to be 180 degrees. Okay, so a straight line is equal to 180 degrees. When I'm using my protractor, remember that when we have a right angle, ooh, that's not a straight line. Let's see if I can get that straight. It's a little, need to move it. Oh, stay. My right angle, we know, is 90 degrees. Okay. So if I am working inside this angle here, you can see that we have these angle measures that are going to start at 0, and it goes in increments of 10 on the protractor. Okay, so increments of 10. So if my angle does not fit perfectly, just like how this one, we can see it perfectly crosses at 50 degrees, I can use my smaller little dot or my smaller dashes to be able to identify if it doesn't match perfectly, okay? So if my 90-degree angle was going that way, I know that once I reach up to 90 degrees, then anything beyond going this way is going to keep going incrementally up to 180 degrees, which is a straight line. Does that make sense? Now, the reason that the numbers are the way they are is because what if I had an angle going this way? So if my angle went that way, then my numbers are going up that way and then that way. Okay, so that's why the protractor has the numbers on the inside and the outside. It depends on which direction your angle, your angle is facing. Okay, so that's the purpose of that. Okay, so when we're talking about measures, we use a protractor to help us to see that. Okay, so we can see where we have the measure of angle BAC is 50 degrees, because when we look in on that protractor right there, you can see where the line crosses through 50 degrees. I would not say it's 130 degrees because, and we'll talk in a minute about the different types of angles. We know that if it's smaller than a 90-degree angle, it couldn't be 130 degrees. So that's how I know it's going to be 50 degrees. And again, if I'm explaining something and I'm not clear and you do not understand what I'm saying, please stop me, because in my head, I understand what I'm saying, but I might not be communicating that very well to you guys. Okay, so at any point, please go, I don't get it. You're not making sense. It will not hurt my feelings. Okay, I'll figure out another way to describe it. Okay, it says angles that have the same measure are called congruent angles. For example, angle BAC and angle DEF each have a measure of 50 degrees, so they are congruent. And so when we use these symbols, you see that the equal sign means is equal to. So if we're talking about the measure of angles, then 50 is equal to 50. But when we're talking about angles, if they measure the same thing, we're going to use is congruent to, and we're going to use our little symbol that is the wavy line on top of the equal sign. That is our symbol that means is congruent to. Okay, so we can see that angle BAC is congruent to angle DEF. But if I was comparing the measures, I would just say that they are equal. All right, so then this leads us to postulate 3, our protractor postulate. Okay, and it says, consider point A on one side of line OAB. The rays form ray OA. The rays of the form of OA, ray OA, can be matched 1-to-1 with the real numbers from 0 to 180. So that's what we were talking about earlier, that because a straight line is 180 degrees, when I start on one side of my protractor and I go around to the other side, I have measures from 0 to 180 degrees. Or if I go from this side over to this side, I know that I'm running through the numbers of 0 through 180 degrees, or 0 through 180. So the measure of angle AOB is equal to the absolute value of the difference between the real numbers for angle OA and angle OB. So again, it's the kind of thing that just because I've passed and gone beyond that 90, I'm not starting to get into negatives. We're dealing with absolute values when we're dealing with angle measurements, okay? We can never have a negative value for an angle measure. We're always going to have positive values. Everybody good with the protractor postulate? Everybody comfortable with that? 0 to 180, it doesn't matter if I'm starting from the left and going to the right, right going to the left. That's why I have numbers on the top and numbers on the bottom. All right, now when we're talking about our angles, we can see that a point is in the interior of the angle if it is between the points that lie on each side of the angle. And the exterior is going to be outside. So interior is going to be inside that angle, Exterior would be the points on the outside. Now we have postulate 4, which is the angle addition postulate. So remember how we talked about, we had the segment addition postulate where we said if I have this segment and I add it to this segment, then I have the whole segment together. We're going to do the same thing with angles. If I have this angle and I add them together, then it makes the bigger angle. So that's what we can see here with our angle addition postulate. If P is in the interior of angle RST, then I know that the measure of RSP plus the measure of angle PST equals the measure of angle RST. And you can see where they've broken it into colors. So RSP is that first little angle, PST is the next angle, and if I add them together, the whole thing is going to be RST. Any questions about that? So if I knew, let's pretend like I knew that the measure of RSP was, let's pretend it's 30 degrees. And I knew that the measure of PST was 50 degrees. What does that mean the measure of RST would be? I would add 30 degrees plus 50 degrees equals 80 degrees. Okay, so if I know those two measures and I know that when they add together, it's going to equal the total measure, all I'm doing is saying this one is this degrees, this one is this degrees, add them together, and that's the total. Okay? All right, calculating angle measures, tongue-tied, just like we just kind of did. This is given an example of a horse. And it says each eye of a horse wearing blinkers has an angle of vision that measures 100 degrees. The angle of vision that is seen by both eyes measures 60 degrees. So it says find the angle of vision seen by the left eye alone. All right, so what they did is they said if I know that the measure of angle 2 plus the measure of angle 3 equals 100, then I could take 100 minus the measure of angle 2 to find the measure of angle 3. So they said that, hey, if I know that that is 60 degrees, then I can do 100 degrees minus 60 degrees, and that will give me 40 degrees. Okay, so by substituting in the values, by understanding that one angle plus the other angle equals something, I can substitute values to be able to find my information. We're going to practice more with that in a little bit. Classifying angles. Okay, so more than likely you have heard this probably 15 times. I'm just kidding. I don't know how many times you've gone over different types of angles, but I know that we talked about it at the end of algebra last year, and we talked about the different types of angles. We've talked about right angles a lot. We know that right angles are 90 degrees. So that's going to be our right angle. We know that they measure 90 degrees. Anything smaller than a right angle is an acute angle. So that means it's going to go anywhere from 0 degrees up to 90 degrees. And our obtuse angle is going to be somewhere between 90 degrees and 180 degrees. And then our straight angle is 180 degrees. So straight line is 180 degrees. Half of that is 90, which makes our right angle. If it's smaller than 90 degrees, it's acute. If it's larger than 90, it's obtuse. Okay, so I know that I've said before, we kind of think about a cute little angle. It's acute, it's cute. So think about cute and little, smaller than 90 degrees. Obtuse, think big, it's obtuse. So you know it's going to be larger than 90 degrees. All right. Okay, so example 3, classifying angles in a coordinate plane. It says plot the points of L, which is -4, 2, M, which is -1, 1, N, which is 2, 2, Q, which is 4, -1, and P, which is 2, -4. Then measure and classify the following angles as acute, right, obtuse, or straight. So what they did is they plotted the points and then they said, okay, if I have angle LMN, so that means I've got to combine L to M and M to N. So I know that these are the ones I'm working with. Okay. So when I look at this, I can see that I have a 90-degree angle. Okay. Then if I look at LMP, okay, if I go from L to M, M to P, that's going to be a straight line, which is 180 degrees. Okay. Then NMQ. NMQ. I'm going from N to M and then M to Q. We can see that that is half of the 90-degree angle, and 90 degrees divided by 2 is 45 degrees. Is everybody following so far? Everybody good with that? So now look at LMQ. If I was doing LMQ, LM, let me do that better. LM and then MQ. I'm doing this whole part right here. Remember, we already said that this was 90 degrees. We just found that this angle was 45 degrees. Using our angle addition postulate, I can add 90 plus 45, and that equals 135 degrees. So 90 degrees is a right angle, 180 degrees is a straight angle, 45 degrees would be an acute angle, and then their 135 degree would be an obtuse angle. Any questions on that? All righty. Example 4, drawing adjacent angles. Okay, so the word adjacent means side by side. Okay, so when we talk about things being adjacent, we're talking about things that are next to each other. So it says, use a protractor to draw 2 adjacent acute angles RSP and PST, so that RST is acute, is A acute and B obtuse. Okay, so the first one in letter A, they're showing that RST is an acute angle. And then in B, they did RST as an obtuse angle. But the main thing was so you can see that they did, as long as my measures are below 90 degrees and add together to equal less than 90 degrees, it's going to be acute. So I have an acute angle plus an acute angle equals an acute angle. Or I can have an acute angle plus an acute angle, and it ends up adding together to be an obtuse angle. Okay, so that's what it's talking about here. If I were to give the directions of drawing, and again, it did not tell them in the directions, it didn't say draw one that's this measure, draw one that's that measure. It just says they could be any acute angles. All righty, so let's take a look at our guided practice. Match the angle with its classification. Okay. So number 1, is this acute, obtuse, right, or straight?
Right.
This is a right angle. Number 2, acute, obtuse, right, or straight?
Straight.
Straight. 3, acute, obtuse, right, or straight?
Obtuse.
Obtuse. And 4, acute, obtuse, right, or straight?
Acute.
Acute. Good job. All righty, let's look at the next one. It says, use the diagram at the right to answer the questions. Explain your answers. So it says, is angle DEF congruent to FEG? So remember, if it's congruent to, it means that they are the same. So I'm looking at DEF and FEG. They have already told us that both of those are 45 degrees. So are they the same?
Yes.
Yes. So they are congruent. Is angle DEG congruent to HEG? So DEG and HEG, are those going to be congruent?
Yes.
Yes. Are angles yes, I'll just use my eraser. Well, erase. Okay. And then it says our DEF, so DEF and FEH, FEH, are those adjacent? Adjacent means side to side. So yes, they are adjacent. Then our angles GED and DEF, are those adjacent?
No.
Okay, so look at those. Notice that it GED and DEF, they are not, because they don't have common interior points. So remember, for them to be adjacent and to be side to side, these have to be their common interior points, and they do not have those. Okay. All right. The next one says name the vertex and the sides of the angles and then estimate the measure. You know, really, in looking at these, you could say, obviously we know this one's going to be 90 degrees and it's going to be a right triangle. This one is going to be less than, less than 90 degrees. So it's going to be acute. This one will be greater than 90 degrees, so it will be obtuse. And this one would be less than 90 degrees, so it would be acute. Okay. All righty, so what we're going to do is, let's look at page 29. Page 29. We're going to do numbers 17 through 20. It says name the vertex and the sides of the angle. Okay, so on 17, 18, and 19, you're going to name each ray and then the vertex. So let's see, this is page 29. Numbers 17 through 19, you're going to name the angles, name the vertex. And then in the next one, write 2 names for the angle. So you would write at least 2 names. There are 3 ways to name each of these angles. You're going to name them 2 of the ways. Okay?
This is 17. Is this 17 through 22?
Yes.
Okay.
Okay. Let's go ahead and turn the page. We will do page 30. Numbers 26 through, let's see, let's do 26 through 28. And then
What are we doing again? 26 through what?
page 30, 26 through 28. I was trying to see if there was anything else to do. I don't think so. That will be all we'll do on that section. All righty, so we've got about 9 minutes. Actually, let's look at section 1.5 real quick on page 34. Page 34, section 1.5. This is segment and angle bisectors. Okay, so it says the midpoint of a segment is the point that divides or bisects the segment into two congruent segments. So remember, congruent means that they're going to be the same. So if you hear the word midpoint, you know that it is a point that is going to be halfway between two other points. Or if we talk about a bisector, that's going to be a line that is going to divide another line into two equal sections. Okay, so midpoint and bisector are going to mean that they are cut, they are divided evenly, they're going to be congruent, which means they're going to be the same. Okay, so if we look at segment AB, we can see that our midpoint is M. If we look at segment AB, we can see that we have a bisector, which is line CD. It bisects at point M. Okay, so one of the things that in drawing things to where they are precise, and we're not going to do this right now, it may be that once we get into the classroom, we may do some activities dealing with using a compass and things like that. And but for now, we're just going to look at it and understand it. We're not going to actually do it. Segment bisectors and midpoints, the way that you can be sure to write them specifically at the correct point is by using a compass. And you can see that if you put your compass, if you started with your point at A, and then you had it, you could measure, you could see where you would set your compass to a certain point, and you would just do a swipe to make that left-hand arc. Then keeping it at the exact same measurement, you would put your point on B and do your left-hand arc. Okay? You can see where these two arcs overlap. Then you would use your ruler to come in and line up exactly where those two arcs overlap, and that becomes your midpoint. Okay, so that's how you find the midpoint of a segment, is you set your compass to be whatever distance you want it to be. That's going to be at least more than halfway over. You swipe to one side, then you put your point on the other side, swipe to the other, use a ruler to measure where they overlap, and that gives you your midpoint. Like I said, it's one of those things that it's good to know how to do. We're not going to do it right now. Maybe when we get back in the classroom, we can do some activities. The main thing is to understand that the midpoint is where you cut things in half. Okay, so that leads us to the midpoint formula. All right, so do you remember at the very end of the year last year, we used the midpoint formula, and we found that if you know the coordinates of the endpoints of a segment, you can calculate the coordinates of the midpoint. You simply take the mean, or the average, of the x coordinates and of the y coordinates and set it up. So basically, this is our midpoint formula right here in the green box. x1 plus x2, we add together our x coordinates and divide by 2. y1 plus y2, we take those y coordinates and add them together and divide by 2. Okay, so that's finding the midpoint. Example 1, finding the coordinates of the midpoint of a segment. So again, it says find the coordinates of the midpoint AB. So we have A, whose points are -2, 3. B is 5, -2. So again, I add my my x coordinates, -2 plus 5, which is going to be 3, and divide by 2. I'm going to leave it as a fraction. Okay, I'm going to leave it, even if it you could even leave it as an improper fraction if you wanted to, but you would so for my y coordinates, I have 3 and -2. I would add those together. 3 plus a -2 is 1, and then divide by 2. So I could find the midpoint of segment AB is at 0.32 1/2, okay? So we can see that this would be where our midpoint is by using that formula. Now it's a whole lot easier to calculate the numbers than it is to actually try to graph that, okay? All right, so what we're gonna do is we are going to stop there for today. This is where we will pick up tomorrow, okay? Quick review of homework. Look at your list that you've written down. Again, all of this will not be due until next Wednesday. I will not be looking for it to be turned in until next Wednesday. So that means tomorrow we won't be going over any homework. We'll just go ahead and pick up with where we're leaving off today, okay? If you want to go ahead and get started on your homework so you don't have it all to do once we get the assignments for tomorrow as well, then that'll have less for you to do if you want to get started on today. But quick review of what our homework is. We have page 21, numbers 23 through 30. Page 22, numbers 31, 32, 33. Numbers 40, 41, 42, and 43. Page 24, numbers 62 through 71. Page 29, 17 through 19, and 20 through 22. And then page 30, 26 through 28.
I missed something on page 29. Could you say those one more time?
Yeah, page 29 was 17 through 19 and 20 through 22, or so basically 17 through 22.
Could you repeat again? Because
Okay, thank you.
I missed like a page.
Okay, y'all ready? Page 21, numbers 23 through 30. Page 22, numbers 31, 32, 33, numbers 40, 41, 42, 43. All of that was on page 22. Page 24, numbers 62 through 71. Page 29, 17 through 22. Page 30, 26 through 28. And that's it. I say that's it. It's just a couple of problems. No, I know it's a lot, but at least it's, you know, it's not difficult stuff right now. Hopefully you're finding that it's pretty easy to do. Okay. So you know what your homework is for the sections that we covered today. If you want to work on it today, that's fantastic. If not, don't stress. We'll have class tomorrow, and then all of this will be due next Wednesday.
What did
Okay.
you say the numbers were on page 30?
Page 30, 26 through 28.
Thank you.
You're welcome. All righty. Well, I hope you guys have a great afternoon, and I will see you guys in the morning.
All right.
Okay. If y'all have questions, let me know.
All right, bye.
Bye. See you tomorrow.
Thank you, Miss Jennifer. Bye.
Welcome, hon. Bye-bye.